Welcome to this KontinuumLAB Instrument Kit membrane build video and tutorial. The membrane is an original KontinuumLAB instrument which uses CNY70 sensor modules together with some balloon membranes to make this sort of percussion-like setup. I originally developed this sensor configuration for the breath sensors in my MIDI wind instruments, but it turns out to work really great for this other totally different use as well. Now this is the original version that I made and featured in my introduction video to the membrane instrument. But there was some confusion about what the best kind of balloon was for this use at the time. And the original build footage spends a lot of time exploring that question. And so I decided to go back and do it again, and that's what we're doing today. We'll get back to this one later in the video. The membrane is very flexible as far as construction goes. Basically any structure which is able to hold the membrane and the sensor module at a distance of about 1 centimeter from each other will do. Plus you have the option to choose between 1, 4, 6 or 8 individual drums as well. So we'll put together a couple of different setups, starting with a cardboard build, then a version which includes 3D printed parts, and finally a couple of different takes on using recycled materials. Even if you don't have the KontinuumLAB Instrument Kit, you should be able to make one of these anyway. You'll just have to source some stuff yourself and download the individual instrument code from the link in the description. But if you do have the kit, then of course you already have all of the electronics and sensor materials that you need for either one of these builds, plus of course the microcontroller with the code already on it for this instrument and a bunch more. So if you want to get your own KLIK and come play along, then head on over to KontinuumLAB.com where you'll find it in the shop. Okay, enough about that, let's get building. So before we get started on this build, I want to just show you this original membrane instrument, which is the one that I featured in the presentation video. So I decided to not use the original build footage from this build because I spent a lot of time talking about how to make these black balloons work for this setup, and that's kind of a waste of time because since then of course I figured out that using metallic balloons is just a much better solution. So that's what we're doing today, and I have a couple of balloons right here. The rest of the stuff that you see here on the desk, of course, as always, on the left we have some basic tools that we'll need, and then here in the middle we have all the electronics like these CNY70 sensor modules, which are specifically the ones that are going to measure the distance to this balloon membrane, and so that's how we're going to be activating the instrument. We'll get back to that. You can also see here the TNC breakout board with the TNC microcontroller already on it, and of course some cables, a couple of rubber bands and some other stuff. And of course over here on the right side we have the basic materials that the user will have to supply for this build. So before we get started on this specific build, let me just give you an idea of the flexibility of this instrument concept. All you really need is some kind of support where you can stretch the balloon membrane over and then be able to put the CNY70 sensor module inside. In this case here I have a normal tin can. This came from some tomato sauce, I think, and that would work just fine. Of course it's not necessarily very easy to work with, and so I also have this other possible support here. This is from I think some facial cream or something that would also work just great. But of course in this case, given that the CNY70 sensor module is an optical sensor, we would need to somehow cover the transparent plastic material because otherwise ambient light and external light sources could very easily interfere with the correct functioning of that sensor. So yeah, you need to keep that in mind. So those are the factors that you have to take into account. But as I was saying, it's just a very, very flexible instrument concept. We could even grab some of this cool bamboo here, cut off a piece of that, and then we would be able to use that pretty much in the same way. So it really just depends on what you have on hand and what kind of result you want to end up with. But I want to make a really simple and cheap version as this first build here, and so I'm going to be using cardboard. I'll be using two different kinds of cardboard to make the cylinders here. The first one is this piece of solid cardboard from a fabric roll. So I'm making some short cylinders here around 1.7 centimeters tall, and that's going to allow me to rest the CNY70 sensor module at the base of the cylinder and have a good distance to the top of the cylinder where the balloon membrane is going to be situated. So that's kind of important. If I make that distance too long, the sensor won't sense anything, and if I make it too short, it will not get really a lot of resolution. So here we have those two cylinders. As you can see, they're not super precise, but they're good enough. The other stuff that I'll be using is this corrugated cardboard. Now I love this stuff. You can make all kinds of stuff with this, and what I'm making today is some similar cylinders to what I just cut out of the tube. And I do that by just cutting out a strip, which is also around 1.7 centimeters tall or wide. And then I'm using this tape roll here to roll it up around, just to give it a good size and shape. And then I'm just going to use some hot glue to hold that in place. As you can see, I've sort of crushed the corrugation along one side of the cardboard strip, and that allows me to roll it in a nice round fashion. Otherwise, it would normally just bend in a few places and make sort of a wonky half round shape with some edges on it. But as you can see, that looks quite nice. So I'm making two of these, and that will give me a total of 4 cylinders. So what I'm making right now is a 4 drum instrument. So here are the 4 cylinders, and these are going to be the supports that I will put the balloon membranes onto. So now we need to make a base for this whole instrument. So I want to make a hollow structure where I can put the electronics inside and then have the cylinders on top. So I'm using a technique that I use really a lot, very, very simple, to make a box out of corrugated cardboard. I'm crushing the corrugation along one side of the cardboard in this specific pattern here that you can see, which is basically 4 strips of corrugation, then 8 strips of corrugation, then 4, and then 8 again. And that's going to give me some regular sides here that I can use to make this sort of rectangular cylinder. And yeah, there's a little bit too much on one side here, so I'm just getting rid of that. The reason why I made it this size, and the way that you will know how to measure it out, is that I just made it large enough to fit the breakout board inside. So yeah, if you're working with a different set of electronics, you could maybe make it smaller, maybe you'd need to make it larger or whatever, but as you can see, I made this so that the breakout board fits perfectly inside. So then I'm going to just glue the breakout board down inside. That's going to help me to keep that in place so that I can build everything else around it. And next up, I'm going to attach a calibration button. I want to just figure out where to put that before I do everything else. I'm going to put that inside the structure here at the opposite end to the breakout board, and then I'm just going to draw a double cable down and plug that into the calibration button plug on the breakout board. And so now that's done, I can get on with making the actual drums. So as you can see, I'm just using a rubber band to hold this closed. You could glue it shut, of course, but right now I still want to have access to the inside. So this is the easiest way of doing that. Okay, so now I'll just figure out how I'm going to put these cylinders on there. And you can really do this any way you want. As you can see, they're not exactly the same size, but that really doesn't matter. I'm just putting a bunch of hot glue on the bottom side of each cylinder, and then I'm just resting it on top of the main structure here. So the important part is that you get a little bit of space in between each, like a centimeter or so at least, because that way you'll be able to easily put on the balloon membrane afterwards. If you butt these right up against each other, that will be very difficult. So now I'm just gluing them down, one, then the next, and then another, and then the fourth one. And as you can see, I'm leaving a little bit of space down where the breakout board is at, and that's just so that the cable that comes down from the inside of that last drum doesn't go straight into the TNC microcontroller. And now I'm applying a little bit of hot glue to the top side of the drums, especially on the corrugated cardboard. This is a good idea because it just gives a little bit of extra strength to the structure, and it also gives a sticky surface which is easier for the balloon membrane to stick to. Okay, so now the actual drum structure is finished and I need to fit in the sensor modules. So as you can see, I'm going for a central placement of the actual sensor module, and that means that the pins on the sensor module will not be in the middle. They will be slightly off to the side. So then I'm just using a small pair of scissors here to make a hole. It needs to be large enough for the triple cable that we're going to connect these sensors with. And so next we get some of those sensor modules and some of those cables, and we can start by just plugging in the cables to the sensor module. Keep an eye on where your ground connection is. It's written on each of the sensor modules, and that will be important once you plug everything into the breakout board. Okay, so now let's open this up and start pulling the cables through. So we pull these through from the outside, and that's not difficult at all. Pull those through like that, and then situate the sensor module where you want it. Put a nice glob of hot glue down where the module will sit, and then we just push it down on top of that, holding it in place until that glue sets. So remember, make sure that the sensor module itself, the black box here, is more or less in the middle, because that's just going to make the sensor work quite a lot better. And then we just do exactly the same for the rest of them, 1, 2, 3, and 4. And as you can see, I've glued them down in the same direction, which is going to make it easier to keep track of where the ground connection is. Let's see. So this is just me pointing out ground and 3 volts. It's written on these small sensor module PCBs. And then this is the ground connection on the breakout board. So we want to make sure that the cable that comes off ground on the sensor module goes into ground on the breakout board. And then I just plug them all into the analog sensor section here on the breakout. And there. So yeah, this instrument has a very simple circuit, no multiplexers, no profusion of string sensors or anything like that. So you just need to make sure that you plug those triple cables in the right direction. Good, so now the sensors are all done and we need to set up the membranes. So the way we do this is that each of these metallic balloons will provide us with 2 membranes. So first I cut off the spout, or whatever you call that part, and then I cut each balloon into halves by following the sort of fold that you get in each one. So now I'm ready to put the individual membranes onto the actual drums here, and this can be a little bit tricky. You need to stretch this out so that you get a nice flat surface, but not so much that a single rubber band can't hold it in place. This is where having put that hot glue on top of each drum actually helps quite a lot. But also keep an eye on my left hand here. I'm holding the edges of the balloon down over the edge of the main structure of the instrument here, and that helps me to keep it taut while I put the rubber band on there with the other hand. So there we go, that's all 4 of them. As you can see, there's a bit of balloon material sticking over the edge, but that's not really a problem. I don't recommend cutting off the excess here, because it would very easily slip out under the rubber band. So now we're ready to plug this into the computer and see if everything works. Okay, so as you can see, that works great, which is no surprise to me, because this setup is almost exactly the same as one of the instruments that we make in my KontinuumLAB workshops at schools, so I've made quite a few of these already. Now, the typical way of using this instrument, which is what I just demonstrated, is for percussion, which is controlled by a simple note-on MIDI message with velocity control based on the speed of your finger. But the instrument also has another setting which allows for continuous volume control, and that's great for controlling other types of synths. Check it out. Okay, so that's the first build, fully functional, but obviously quite cheap looking. Let's see if we can't put together a more polished version. Okay, so we're ready to make another version of this instrument here. As you can see in the middle, we have exactly the same stuff as before. On your left side of the screen, we have the same tools as before, but on your right side of the screen, as you can see, there's a bunch of new stuff going on, including some 3D printed bits and pieces. Okay, so first let's have a look at the stuff here that's different. This is the stuff that you will have 3D printed if you want to make this. And of course there's also this sheet of material here. This is the polypropylene, or fluted plastic as it's often called. It's about 5 millimeters thick, and this square piece here is about 25 by 25 centimeters, more or less. It's not super important that that be very precise. So to make this main structure for this instrument this time, I'm using these two printed end pieces here. I call these box ends. And these are the same ones that I used for the C board, and that's why there's a round hole in one of them. That's the hole for the breath tube when I made the melodica version of this instrument. But we're going to just ignore that hole. I actually have some other versions here without that hole in them, but these are a little bit too small because the largest one of the drums that we're making is just pretty huge. So we need this slightly larger box end to make that work. So, okay, now let's talk about these 3D printed pieces here. Let's call this main cylinder-shaped piece here the drum. So there's 3 different sizes, but apart from the size, they're pretty much exactly the same. As you can see, there's some structure inside them, and that structure is meant to help hold the other 2 pieces in place. First of all, we have this, let's call it the membrane ring, or just the ring, and that, of course, is meant to hold and stretch out the membrane to make the top side of the instrument. And then the third piece that we have is there to hold the CNY70 sensor module. So this is the sensor holder. So now we have the drum, the ring, and the sensor holder. So as you can see, the CNY70 fits right into there, and then this piece will fit right inside the drum. And of course, everything is printed in 3 different sizes so that they all fit together. So the way you fit this in there is you put it down diagonally, and then you twist it around until it snaps into place. And that's what it looks like when it's done. You'll feel it snap into place, so it's not that difficult to put together. And you don't need any screws or any glue or whatever to hold this stuff together. Here is the medium-sized one. Put it in diagonally and then just twist it. Let's see. Just twist it, almost there. Snap, and now it's centered. So there you go. Okay, so that's all 4 of them. Now we have the sensor holders in place with the sensor modules inside, and we're ready to make the main structure to put these drums onto. So of course the way I'm doing this is the same way that I always use these box ends. I use the box end itself to measure out a length of this corrugated plastic material here, and then I'm going to use the corrugation structure itself to help me fold the material. So the way I do that is I grab my Stanley knife here, I put the blade at the minimum setting so that I only cut one side of the corrugation, and then I just slide down 3 of the corrugation sections like that, and then I'm going to get rid of the surplus plastic that's stuck in between those slits, and that's going to allow me to then bend the plastic inwards, hiding the cut part and leaving a nice rounded edge on the outside of the instrument. This provides a lot of structural stability because the corrugated material itself is very stable in one direction, and of course folding it around like this gives it a lot of stability in the other direction. So last minute I just decided to take out a 4th section of the corrugation because the fold was a little bit too sharp. So you need to know that when you buy this material, sometimes the sizes are not exactly uniform. So sometimes the corrugated sections are a little bit narrower or more wide. Sometimes the material is a little bit softer or harder, and so it can be sort of hard to know exactly what cuts to make. And that's why I use the 3D printed box end itself as a measuring device, and so I make these measurements as I go along. I just make sure that the polypropylene sheet is big enough, and then you can always cut off the surplus once you're done. So you can see I'm repeating this same action all the way around the box end piece, using that as a measurement device, and there's going to be one final cut a little bit further down, but I'm going to save that until I've glued everything together. So now I'm making some small cuts on the ends that will glue to the box end, and that's going to help the hot glue to keep everything in place. The hot glue isn't hot enough to actually melt this polypropylene, and there's no sort of chemical bond at all. We need strict mechanical strength to hold this together. So now I'm applying a bit of hot glue, well, quite a lot of hot glue, to the end of the corrugated sheet and then to the inside of where it's going to fit onto the box end. So and then I'm just going to apply the box end while I hold that fold in the polypropylene in place with my other hand, trying to make sure that everything stays in place while the glue sets. Don't worry about surplus glue that goops out over the side here. You can always get rid of that afterwards. So once one side is glued onto two edges of the box end, then I do the other end of the instrument. So that's going to help stabilize everything. That's how I do that. So I try to hold that edge, especially the corner, in a nice shape while the glue is setting, just so that it looks good when I'm done. So okay, that looks nice. As you can see, I also did a couple of cuts here on the inside of the fold, and I'm just going to apply a couple of big goops of hot glue, which is going to help to stabilize the shape of the instrument along the middle of the structure. So now you can see that now you're starting to see how this all fits together. Now I'm going to do the third edge of gluing. I'm doing both sides at the same time here. Again, some glue on the end of the polypropylene, and then some glue on the edge, inside edge of the box end, and then just hold everything in place while it sets. And then once again, I'm going to apply a couple of drops to the inside edge of the fold itself, where I also made a couple of small cuts right there, just to give some structural stability. Okay, and so now everything's looking pretty good. This part here that still moves is what I consider the lid. This is actually going to be the bottom side of the instrument, but it is the lid. It's the part that will open up so you can access the electronics inside. And so that's not going to be glued in place. It's actually going to fold inside the instrument. But of course, to do that, I need to make some small cuts along the edge, because right now the piece is too wide to actually fit inside. So that's what I'm doing here. Again, I'm just using the box end as a measuring device, and then I'm cutting off about 4 or 5 millimeters on this end piece. And that's going to, as you will see in a second, allow me to fold everything together neatly. So there, now you can see how that works. So now I just need to repeat the action from before, where I make this fold in the corrugation, and so I'm making another couple of cuts down here where I wanted to fold, and that's going to make this final flap here that I'll be able to actually fold right inside the instrument, where it will completely disappear and will help to hold the instrument shut. So let's see if that fits in there. Okay, so the tension from the material itself is more than enough to hold this shut, and so that's very nice. Excellent. So yeah, there you go. I'm very happy with that, and it can easily be opened up again. Just apply a little bit of force here with your thumb, and that comes right open. Excellent. So the next thing I want to do is I want to insert the breakout board. And of course, one of the box ends has a cutout where the USB cable will go through, and that comes through right there. So notice here that I'm putting the breakout board on the lid structure. I'm not putting it in the bottom of the instrument. So that will make for a much easier access. And so now I'm just first plugging in the USB cable, then applying a couple of globs of hot glue to the breakout board itself, and then I'm going to close the lid right on top of that. So now that I'm holding on to the USB cable with my right hand, that's going to make sure that the breakout board stays in the right place. Then when the glue is set, I can unplug the USB, and then I can open up, and there you go. That's a pretty decent placement, I think. And so now I have very easy access to all of the different parts of the breakout board. Next, I'm going to insert the calibration button. There's also a little cutout for that. I'm going to apply a dab of hot glue on the side next to the hole where the little button module will go, and then I'm just going to insert the button module in there. I'm applying a little bit more hot glue on top of it. Not really necessary. It should stay in place by itself, just under the tension of it. And so now that's in place. That's looking pretty good. So next, let's find out where we want to put these drums here along the top side of the instrument. So remember, this is the opposite side to the lid. So this is the static part that's glued in place. And I'm just putting these down and then marking where I want them to go with a marker here. permanent marker. It doesn't really matter, it's all going to be hidden underneath the drums. And I'm making a cut that's large enough for these triple cables to fit through. And so that means I'll actually have to make 2 cuts in parallel, about 3 millimeters, 2 or 3 millimeters from each other. And then I'm just going to remove the material in between those 2 cuts. So something like that. Gonna do that same thing down for all 4 of these drums. This material is pretty easy to cut through. You want to be careful that you don't accidentally make a huge cut or a big gouge in there, so just pay attention to that. Okay, so that's what those holes look like. Just removing the excess material in there in the middle. Trying to just remove the necessary stuff, not too much. So now you can see that the plugs there fit right into each of their little holes, and that's looking pretty good. Okay, so next thing is to pull these cables through, but I'm just thinking something here. I think I brought these 200 millimeter cables, but now I can see that that's barely long enough to reach from the hole and down to the breakout board. So I'm going to change this last one here for a 300 millimeter cable, and then that should be more than long enough. So let's check that. Pull the cable through there. Actually, let's just pull all 4 of them through just to see what that looks like. Okay, so that works great. Now we can plug in the individual sensor modules, and then we can just fit the drums down into place. And yeah, so that's looking really nice. All 4 of them fit in there easily. Cables all connected. And then I just remembered that even though I inserted the calibration button module, I never actually plugged the cable in. So let's just get that out of the way. That's just a double cable like that. Goes into the calibration header on the breakout board. And then, of course, once again, we need to keep track of where the ground connection is on each of the little sensor modules, because that's going to just allow us to plug them in the right way around down on the breakout board, which is important for them to function properly or at all. So there you go, 1, 2, 3, 4, and everything's connected. Excellent. So now let's close this up with the drums on there, and just to check out what it looks like. And if we're happy with where everything is set, then we're ready to glue the drums down. So I'm just putting a drop of hot glue on each corner of each drum. Nothing major here, nothing fancy going on. Just gluing each one down in the correct position, trying to keep it more or less neat. And pretty easy job. There. Excellent. And damn, that's looking pretty fine. So now it's time to put on the membranes. And as I mentioned, we have these rings here, which are going to be the support for each membrane. Just like before, we're cutting up some balloons for this. I'm cutting up 2 balloons. First cut off the spout or the mouth of the balloon, and then cut the main section into 2 halves following the fold that they naturally get from the factory. And then this part can be a little bit tricky here, especially on the larger ones, but as you can see, I'm pretty good at it. You need to sort of fold the balloon down over the edge of the ring and then hold it in place between like all of the fingers on one hand. And then you can get the balloon around. There's a channel all the way around the disc, all the way around the ring, which is then going to hold the balloon in place. And in this case, now with these rings, we do want to cut off the excess. So once you use a balloon for one of these membranes, you can't really reuse it for that again, because it would be very difficult to get on there once it's cut down to size that sort of neatly. But you do need to cut off the excess, because you have to fit this whole setup inside of the drums, and so that doesn't really allow all of that excess balloon material on there. But as you can see, once they're cut down to size, they do fit in quite neatly inside each drum. And there you go. And they sit in there just under their own tension. Again, no screws needed or anything fancy like that. So for the larger ring, I only put the rubber band around once, and that's enough to hold the balloon in place. But for the smaller ones, I put the rubber band around twice, and that makes a lot of tension, which then holds that in place. Okay. Damn, that's looking really nice. I'm just noticing that this has a real sort of Captain America theme vibe going on. So anyway, that doesn't really matter. We need to see if this works. So it's time to plug it into the computer and see if we can't make some noise. Okay, so there you go. Obviously this one does exactly the same as the previous build, just with fancier materials. So yeah, not a lot to talk about there really. Except to mention that this is the instrument that Captain America would probably play if he were a musician rather than a superhero. I also want to point out that these 3D printed drum sections here come in two different versions, where this is one and the original membrane build uses the other. The main difference here, of course, is that these drum sections are embedded inside the instrument, whereas these ones stick out on top. The other important difference, of course, is that this one has 8 drums instead of just 4, so double the fun. Great, so finally, let's throw together some quick alternative drums using some recycled stuff. I won't go into much detail here because it's pretty much all the same. So of course that fancy 3D printed stuff works just great, but what if you only had the materials that I mentioned in the beginning of the video to work with? Would you still be able to make some functional drums? That's what we're going to try right now. So we're starting with this tin can here, and the inside edge has this sort of dangerous sharp edge on it. I already cut my finger more than once, so I'm using a screwdriver to just flatten that. And there you go. So now it's a little bit less dangerous. Next thing we need to figure out is how high we want the CNY70 module to sit inside of this instrument. And we of course want the same, basically the same distance as we had on the other instruments, and that means that we want the base of the sensor module to be around 1.5 to 2 centimeters away from the membrane. So I'm just making a piece of cardboard here that's going to fit inside of the tin can, and that's going to be the support for a little platform where I will put the sensor module on. Really basic stuff. We just want to make sure that we get the right distance between sensor module and membrane. So there you go. That's going to be like an inner wall where I can then make this sort of another piece of cardboard that's going to be a platform that's going to fit inside there and sit on top of that, and it's going to support the sensor module. So I'm just cutting that in a roughly round shape, and then once again I want to fit the sensor module on there. We need to get the sensor itself more or less in the middle, so that means the pins have to go through the cardboard somewhat off to the side. Just making a hole there which will fit just like before. This triple cable, really simple stuff. Then we can pull the cable through, and yeah, that works pretty good. So now we need somehow some kind of exit hole for the cable. Of course, we need to pull the cable off and get it to the electronics somehow. We're going to plug this into the breakout board just like before. So I'm using my poor Stanley knife to cut a hole in this. That's not really recommended. I sort of messed it up a little bit, had to change the blade afterwards. Also, the hole really ended up pretty ugly, but it works. And we're going for just something that functions here. We already have some pretty drums that we can show off to our friends. Right now I just want to show you just how improvised this can be and still work. So now we're pulling the cable through, we're putting some hot glue on the top of that inside cardboard wall, and then we're taking our cardboard platform and just putting it down right on top of that. So now as you can see, we have that sensor in the middle just like we want, and we're ready to apply our membrane. Just like before, we just grab one of these metallic balloons, cut off the spout, cut the balloon in half, and then we can use one half as that membrane. And just like before, this is a little bit tricky, but you'll figure it out. Stretch the balloon over there, making sure to have enough surplus material over those edges to get the rubber band on top of it, and we're done. Check it out. As for the other container here, I really won't bore you with the exact details of how I did this, because it's exactly the same as what I just did with the cardboard. The measurements are a little bit different, but it's exactly the same. The important thing here is that we need some kind of opaque tape to cover up the outside of this plastic, as I mentioned, to protect from ambient light and other light sources. We just get the membrane on there, and we're done. There. The membrane instrument allows for a single sensor setup, which is selected on the breakout board. Okay, so that's quite practical if you're testing a new drum design or build technique, but it's not very interesting to play. So let's instead connect these two to our initial build and then select a 6th sensor setup on the breakout board. And that's it. The membrane isn't the typical way that someone would make a MIDI percussion instrument, which normally involves piezo sensors in a completely different interface. But this concept does offer some unique qualities, like the flexible and tactile nature of the interface itself. Like I mentioned, we do make this instrument in my KontinuumLAB workshops, and the kids really enjoy it. Keep in mind that all of the instruments in the KontinuumLAB Instrument Kit also have a companion video, which is published shortly after the tutorial. The companion videos go into more detail about how to calibrate and play each instrument, as well as the different options and settings that you can choose between. So if you're curious about that, there will be a link in the description. And that's all I have for you this time. Go check out the other build videos and tutorials right here on the channel. And don't forget, you can buy the full KontinuumLAB Instrument Kit over at KontinuumLAB.com. Take care until next time, and I'll see you in the Kontinuum.